Example 1 here on basic trig identities is taking a look at being able to adapt equations. So in this example here, we're asked to find the values of x between 0 and 2 pi such that cos x minus tan x equals 0. So to start with, let's just write down the original equation. So cos x minus tan x equals 0. Now here, before we actually start this equation here, let's just denote the two identities that we're familiar with. The first identity that we should be familiar with is the idea that tan x can be expressed as sin x over cos x. There's also another identity that we should be familiar with here, and that's the identity that sin squared x plus cos squared x is 1. Now we may only need to use one of these identities, we may need to use both, but for now we've got both the identities denoted here, so we can easily refer back to them. So taking a look at our original equation then, cos x minus tan x equals 0. So in this case now, we take a look at cos x and tan x. So cos x on its own, we can't do too much with that. However, tan x, we've just denoted the identity for this expression. So if we replace tan x here with sin x over cos x, we may be able to manipulate this equation here and adapt it. So therefore, if we rewrite this, this gives us cos x, and we minus here sin x over cos x. And if we just use the correct pen colour here, such that it links to its corresponding identity, so we obtain sin x over cos x. And this is equal to 0 still. Now here, we want to get rid of this denominator of cos x, so what I'm going to do here now is multiply through by cos x. So we obtain cos squared x minus sin x is equal to 0. Now here again, we just need to take a look at what we've got. We've got cos squared x and minus sin x. So this minus sin x, we can't do much with that. However, cos squared x, we can actually use our blue identity here. The identity of sin squared x plus cos squared x gives us 1. Well, in that case, if we rearrange this to be cos squared x is equal to our expression, then we can simply substitute that back in, and we obtain a quadratic in terms of sin x. So therefore, referring back now to our blue identity here, if we make cos squared x the subject, that's simply going to give us 1 minus sin squared x. Okay, so 1 minus sin squared x. So all we need to simply do here now is substitute this expression into cos squared x. So therefore, 1 minus sin squared x minus the sin x here, so minus sin x is equal to 0. And in this case here, as the sin squared x is negative, all I'm going to do is take everything to the right hand side. So therefore what we obtain here is sin squared x plus sin x minus 1 equals 0. Okay, and what we've got now here is a quadratic. And in this case, if you prefer, you can write this as a disguised quadratic. So if we let y equal sin x, here, then in that case, this quadratic could be written as y squared plus y minus 1 equals 0. Now we can check to see if this quadratic factorizes. However, for this example, it unfortunately does not factorize. So in that case, we need to refer now to the quadratic formula. So therefore, applying the quadratic formula to this quadratic here in terms of y, what we obtain then is that y is equal to minus 1 here, so that's minus b plus or minus the square root here of 1 squared minus, and then what I do here is I put everything in a bracket. So this is 4 times by a, which is 1, times by c, which is minus 1. And this is all over 2a. So that's 2 times 1, giving us 2. And in that case then, if we just simplify the square root here, what we obtain is minus 1 plus or minus the square root of 5. Okay, and this is all over 2 still. So in that case then, if y is equal to sine x, then what we're saying here is that sine x is equal to minus 1 plus or minus the square root of 5 over 2. However, we have to be slightly careful here, because in this case, sine x cannot be equal to minus 1 minus the square root of 5 over 2. Okay? That would fall outside of the range of values for which we can find the inverse of. So therefore, sine x cannot be equal to minus 1 minus the square root of 5 over 2. So therefore, sine x is just the positive solution here. So therefore, sine x is simply minus 1 plus the square root of 5 over 2. Now in this case, all we simply want here is the values of x. So therefore, if we take sine inverse of the left hand side and the right hand side, we're going to obtain the solutions that we need here. So therefore, x is equal to sine inverse of this expression here, so minus 1 plus the square root of 5 over 2. And if we put this into our calculator here, making sure to take care that we're using radians here, then in that case, what we obtain here is 0.67 radians and 2.48 radians there. Okay, and that gives us the solution there to example 1 on adapting equations.